Hello, thanks for tuning in. My name is Chris Lillard. This is Lab 7 as a part of the Virginia Tech course ECE 5674 Software-Defined Radios, and the lab name for this is called Diversity Combining Using Unsynchronized Receivers. We'll jump right into it because we only have a couple minutes to get through everything. So this was a 3-part lab. I'll go through and show what I did for the first 2 parts with this flow graph here. Basically what I've done is taken everything and just split it up into higher blocks. So we've got a transmit sub-block, we've got our channel sub-block here, a receive sub-block here, and then we're doing some comparisons in the GUI plot down here, and we also have all of our GUI sliders and choosers and ranges here. So if we go to the TX sub-block first, just very quickly, this is very similar to Lab 6, where I've got my audio source coming from a Spotify web player that's being piped in through an null-sync that I am using pulsed audio for. We also have our text-to-speech file here coming in, and that's also the same as Lab 6. We're throttling here. We've got a selector choosing between wideband and narrowband, and that's just selfishly because I wanted to hear a little bit better quality music when I was working on this lab. And then we're going out to the sync. So from there, we're going into the the channel block here. So you've got your pad source in. Once again, going to a different selector. This selector is being dithered by output index of fade select, which is the same variable as the selector on the other side to go from fading model A to fading model B. The parameters that we're changing in the fading models, most of the time are just the max stop numerator A, and then we're normalizing that to the sample rate. And I just did that so that we could use it in units hertz in the GUI. And we just left it as the Rayleigh, non-line of sight multipath model there. This is for part 2. This is actually pretty similar to what you had asked for in that initial part 2 before the update. And so I did use ChatGPT to help clarify, I think, what was being asked. So hopefully I got it right. So anyways, what I was after here was that, that 0.1 hertz frequency, which is the slew rate of that frequency offset, and then an amplitude is going to be the maximum offset, and that's just passed in as a parameter here that will change, on the top block side. So that's being passed into a voltage controlled oscillator of the same sample rate as everything else here, a sensitivity of 2 pi and an amplitude of 1. There's another throttle block here. It was working for me when I was just looking at like an A440 input, and then I forgot that I had a throttle block on the Spotify and the other transmit options in the transmit block. So I bypassed this one for now. And then that's going to the pad sync. We've then got our receiver, which is coming from the channel here. So the selector down selects to a single output that goes to the channel. We reselect here based on the wideband or the narrowband modulation scheme that we used earlier. The DC block I incorporated because when I was passing that frequency offset in, we were getting a huge DC spike that was doing some unfriendly things to my speakers. So we threw a DC block in there, and that took care of that. We've got our audio gain, we've got our pad sync, and then this is the audio sync that we're actually going to hear on the speakers. And then we look at that all together. We can just go ahead and quickly go through because I think we're already, over 3 minutes here. So here's our music. Here's our test tune. I've got a number station, or what, the closest thing that I could do to one of those creepy number stations. One thing that I found is that actually if you go to this really makes the processor churn, and so when you go back here, even the output on the Spotify source is a lot less smooth. So I'm going to go ahead and get out and do this again and kind of show you the difference. So that just looks a lot cleaner. For some reason I wasn't really able to get around that, and I think it might have something to do with just having to kind of optimize the text-to-speech Python function that we've got in there. So let's go ahead and shift this to the lab specification narrowband FM. We've got channel A and B that we can set here with the number of signs for A. This is more important for us, for our case, is the max stop of A and the max stop of B. So then you can kind of hear those differences. And we'll bring this down just a little bit because I think, honestly, some of the biggest differences are between, sub-hertz and then just barely over 1 hertz. So there you can kind of hear the speed of it kind of as it fades in and out with that Doppler change. And then if we take those off, we turn on our, oh, sorry, let's go back and add some max Steve. And make this kind of an appreciable portion of our sample right there. You can kind of hear that fading in and out. Let's see if it comes back here in a second. There we go. And you can see with channel A that it's not really present. You can change the noise amplitude there, but you don't really get any change from this. This does kind of nothing for us. So for part three rather, this is kind of where I flew a little bit too close to the sun here and thought that I could, I had everything kind of working up, and the way that I had imported your higher blocks, I had changed the maximum ratio combining from a higher GUI block to just a higher block. The EGC was already just in the form of a higher block, if I remember correctly. And the reason I did that is because all I wanted to do was change the way that I was selecting these fading models, so that instead of selecting from fading A to fading B, I was actually going in through, this Chan sub V2 and then, therein selecting either your maximum ratio combiner or your equal gain combiner instead, and just having them both passed in that way. And then my plan was to take that back out here to the top block and use the raw audio out. So your X and then your Y after the essentially the transfer function here of your channel, using those two as the means by which I would calculate my SNR. So I didn't get that far, and the reason for that is because I spent quite a bit of time debugging. I had something on the output of this, and I don't know what I changed. Oftentimes it's just trying to turn too many knobs at once. So I do apologize for that. I am still going through and debugging this right now, but I can kind of show you what happens when I so even strangely enough, even when I'm just passing straight from source to sync on both sides here, just combining just like that. I've done this for both the maximum ratio and for the equal gain, and then for my channel. So really this is just passing it straight into an add, and then to a select, and then to a sync, and then we've got a version 5 here for Lab 7, which incorporates, as you can see here, this channel subblock too. And like I say, I swear I had it working with an output that I could get a difference between the two on, and then something changed, and I'm still kind of working through the issues with that. So not able to get anything here, which is kind of, I don't know, not really that remarkable. I feel like, there's so many things that we're doing and changing here that it just takes a little bit more time than I've allotted myself to get through the debugging. So I'll let you know if I have an update for that. I don't expect any change to the, the obvious demerits to the grading for not having that part in, but I do think it would be an interesting thing to be able to go through and fix and see why something that isn't really overly complex would kind of fall apart like that. So hopefully I'll have an update for you, but thank you so much for listening to this portion. Take care.